Today, join me on an expedition to discover the wonders of Pluto. Now, you might remember Pluto as the ninth planet, but in 2006, it got a cosmic demotion and is now called a dwarf planet. That shift caused quite a stir, shaking up what we knew about our solar system. But even though it lost its planet tag, Pluto's still a star in its own right, chilling way out there, teaching us loads about what it means to be a planet. So stick around because we're diving into Pluto's journey from the ninth planet to dwarf planet and why it's still one fascinating space neighbor. We will cover all that and more in today's video. In today's video, we are exploring Pluto's wonders. Pluto, positioned approximately 40 times farther from the Sun than Earth, orbits the solar system center every 248 years in an elongated path. Its small radius of 1,188 kilometers makes it notably smaller than all planets and even some moons, including our own. Despite its mass being a mere 1.3 times 10 to the power of 22 kilograms, about 1/18 of our moon's mass, Pluto shares similarities with smaller celestial bodies like Ceres or Sedna. This classification led to its designation as a dwarf planet in 2006. Due to its elongated orbit, this distant object experiences a lengthy orbital cycle, reaching its closest point, perihelion, to the Sun at 29.7 astronomical units in 1989. However, it will hit its farthest point, the aphelion, at 49.3 astronomical units in 2113. Because of its extreme distance and dimness, Pluto remains invisible to the naked eye and appears as a murky brown disk, lacking surface details even in Hubble Space Telescope images. The New Horizons uncrewed station embarked on a mission in 2006, taking 9.5 years to reach Pluto. It transmitted over 6 gigabytes of data and captured around 400 observations during its 2015 flybys. Unfortunately, due to its trajectory, New Horizons couldn't photograph the entire surface, but circled around to explore other celestial bodies. Regarding its structure, current models suggest Pluto possesses a substantial core, roughly 1,700 kilometers in diameter, composed of ice and rocks. Enveloping this core is a 300-kilometer ice mantle, possibly undergoing tectonic activity that remains relatively unstudied. A surface crust of crystallized gases, nitrogen, methane, and carbon monoxide, caps the mantle. Some theories suggest that Pluto's core produces enough heat to melt parts of the icy mantle beneath its surface. This might create a deep, salty, and hazardous ocean containing lots of dissolved ammonia. The planetoid's surface temperature is frigid, not surpassing 60 Kelvin or negative 213 degrees Celsius. Now, let's continue our exploration of Pluto with one of its most notable features, the Tombaugh Regio. This expansive region sits along the equator, resembling a heart-shaped sketch, covering about a quarter of Pluto's surface with a size of 2,300 kilometers. The Tombaugh Regio isn't uniform. Its western part, Sputnik Planatia, spans 1,492 kilometers and appears smooth, lowland. Sputnik Planatia is coated in nitrogen ice, carbon monoxide, and solid methane. These substances give it a light hue, reflecting up to 90% of the incoming light. Surprisingly, it lacks many craters, indicating its relative youth in geological terms. One widely accepted idea suggests that Sputnik Planatia formed around 100 million years ago after a colossal collision with another celestial body. This impact created a massive crater filled with material from Pluto's hypothetical inner ocean, which promptly froze. The terrain's features, like smooth areas bordered by hills and depressions, resemble convection cells seen in heated fluids. This suggests clues about the frozen ocean's behavior under extreme conditions. This provides evidence supporting the theory of Pluto having a warm interior. Tombaugh Regio is encircled by notably high mountain ranges, with Hilary Montes situated to the west of Sputnik Planatia and reaching heights of about 3.5 kilometers. These mountains, known as Tenzing Montes, are positioned in the southern area of the heart of Pluto. Some of these peaks soar over 6 kilometers above the dwarf planet's average surface level, making this ridge the tallest one discovered on Pluto. Remarkably, these formations are predominantly composed of water ice, which under the extreme cold temperatures of Pluto becomes as solid as rock. Moving southward reveals a profound basin surrounded by substantial, layered ridges of ice and rock. This area is speculated to be the outlet of an ancient cryovolcano, with the adjacent rock formations believed to be frozen residues from its eruptions. Understanding the chemical composition of these formations is crucial for scientific exploration, as it offers insights into Pluto's internal structure. The eastern segment of Tombaugh Regio appears darker and is marked by numerous craters, suggesting it is significantly older than Sputnik Planatia. As we venture eastward along the equator of Pluto, we encounter a series of significant dark spots known as maculas. These expansive features, some hundreds of kilometers wide, derive their names from various dark deities across cultures. One such macula is named Balrog. Collectively, these maculas create a colossal formation known as the brass knuckles, encircling the celestial body along its equator. Separated by towering mountain ranges, these maculas exhibit surfaces marred by extensive crevices, some stretching hundreds of kilometers. The most prominent, Cthulhu Macula, extends westward from Tombaugh Regio, spanning nearly 3,000 kilometers. Reflecting a mere 30% of the incident light, it presents a striking contrast to the nearby bright and luminous Sputnik Planatia. While the precise nature of these maculas remains elusive, it is hypothesized that their dark hue stems from a high concentration of tholin and numerous impact craters. This suggests their remarkable age. Cthulhu Macula's surface is diverse, featuring undulating relief in the western part, a smooth plain in the central region, and an eastern section adorned with mountains and craters. Moving away from Cthulhu Macula towards the north, we encounter Lowell Regio, a vast valley encircling Pluto's north pole. Surprisingly, this area is currently the most illuminated part of the dwarf planet's surface. This unusual illumination results from Pluto's significant axial tilt, causing its north pole to face the sun. Consequently, despite its increasing distance from the sun, Pluto's atmosphere has notably thickened over the last 3 decades. Solar rays are suspected to evaporate nitrogen ice, concentrating at the poles and contributing to the planet's atmosphere. Pluto's orbital dynamics set it apart from other solar system planets. Apart from its considerable tilt concerning the ecliptic plane, Pluto experiences cyclic oscillations near a specific point in its orbit due to the gravitational influence of its large satellite, Charon. With a mass of 1.52 times 10 to the power of 21 kilograms, approximately 11% that of Pluto, Charon creates a shared center of mass between the two bodies, resulting in tidal locking. Consequently, both Pluto and Charon always present the same sides to each other. Like Pluto, Charon's surface exhibits significant darkness and showcases abundant water ice mixed with methane and nitrogen in select regions. Charon, along with other satellites, orbits Pluto. Most of these satellites are smaller and have irregular shapes. For instance, the Nix and Hydra, discovered in 2005, are several tens of kilometers in size. Subsequent discoveries like Kerberos and Styx are even smaller, not exceeding 16 kilometers in diameter. These celestial bodies are primarily composed of water ice and were likely drawn into Pluto's orbit due to its gravity from the Kuiper Belt. Unfortunately, during the New Horizons probe's mission, its cameras didn't capture a substantial portion of Charon. However, visible features on its surface have piqued interest. For instance, south of the equator lies the Vulcan Planum, spanning an area of at least 400,000 square kilometers, comparable to the size of an average European country. This region boasts the tallest summit on Charon Kubrick Mons, with a diameter of around 40 kilometers and an estimated height of 4,000 meters. Some suggest it might be a cryovolcano, possibly causing the surrounding air to sink due to underground reservoir activity. Moving north, the Ozterra is marked by numerous craters and separated from the Vulcan Planum by towering ledges and crevices, reaching up to 1 kilometer in height. Serenity Chasma, the largest among them, stretches 200 kilometers in length, 40 to 50 kilometers in width, and possibly plunges 7 kilometers deep, making its exploration challenging due to steep shadows. Closer to the pole is the enormous Mordor Macula, approximately 475 kilometers in diameter, whose origin is still a subject of debate. The prevailing theory suggests that nitrogen and methane from Pluto's atmosphere might have gathered at Charon's poles, transformed into tholin due to ultraviolet radiation, and concentrated in its ice. This hypothesis requires further exploration of future missions. Charon remains largely enigmatic, as our research has just begun. Despite being one of the most intriguing structures in the solar system, the Pluto-Charon system is vastly unexplored. The New Horizons probe departed long ago, and these celestial bodies continue to move away from us, carrying their mysteries. Presently, the probe is over 50 astronomical units away from Earth, intermittently transmitting crucial data. By 2030, its systems will likely fail, leaving the probe isolated in the depths of space, leaving us with the task of deciphering the data it has sent before its demise. Thanks for joining me on this exploration of Pluto. If you got value from this video, hit the like button and feel free to leave a comment, as it supports our work and helps boost this channel to new orbits. Also, click the subscribe button below so you'll be in the cosmic loop when we release new videos. Until next time, stay curious, keep exploring, and I'll see you in the next video.